Hi, my name is Buitrago. I'm here with Maritza Londoño. We're from the Universidad Nacional de Colombia, so the Medellin, from the student chapter, where I'm the vice president. And here we have a little experiment that intends to show that optics is a quite open field where everybody can find a little place. Our university is a place that is mainly focused on engineering careers. That means that a lot of people find optics and physics in general like a dangerous zone in which they don't want to enter. With this, we want to show that optics is everywhere, and even from the simplest concepts, we can get involved. So the system is, although it may look confusing, it's quite simple. We've got an audio input that goes into the system, it gets amplified and runs a current, steady current for the laser. What it does is that it modifies the intensity that gets to the laser so that when it gets to the other side, when we've got the receptor, take this off, it can be converted into voltage peaks that get represented again as the sound that were coming out of the audio device. So let's take a look. Plate. That's it. So the laser beam does look like any other laser pointer you have ever seen, but when we get it up to the receptor, we find that the music that is being played on the iPod gets transferred right through the air and onto the visible light into the receptor. Although in this case we're seeing a lot of noise, it's due to the ambiental light. I don't know how to call them. Okay. Okay. And we can see a lot of applications based on this very simple principle. This is how a lot of communication works nowadays. It's becoming the next step into the future in communications. Something as we've been hearing for years about Wi-Fi and transmitting data or internet over the very light that compose our daily lives can become a source of information. This one here has the additional advantage of being completely private. While Wi-Fi and radio applications have a lot of advantage right now, they are omnidirectional, meaning that they go around everywhere, and everyone, although they will need to know how to decode it, could access that information. With visible light communication, we've got the advantage of knowing exactly where that information is going. So, where the laser beam is pointing, we've got that information. But whenever it is interrupted or goes another way, the information is completely lost and it goes right where the laser goes. So it becomes an essential element in security communications, as one can detect when there has been made an interference with the communication.